or a bunch of computers on the other side of the router, what has to be, what do we have to know about those two networks? Like
they have to have a different network address.
They have to have a, if you're going to route packets, right? If you're going to route packets, they have to have a different network address at the destination than they do at the source. Okay? So have we missed any rules? Have we missed any rules? All right, and let's do this. Let me review those rules real quick. Everybody get out something they can write on. If it's OneNote, that's fine. Can everyone see that? Or do I need to make it larger? Now can you see it? Austin, can you guys see that? All right, there we go. So if you use these rules, take a look at the screen, if you use these rules, then no matter what problem we give you, if I give you 3 computers right here, and let's pretend that's a router even though we all know it's not, right? It's an access point. And I give you that device, and I give you 3 more computers over here. If you know these rules, and pay attention to these rules, and think about them, and apply them every time you address a device on that network, or either one of those networks, then you're going to be successful. Then you'll be successful, and you'll do it. Okay? So, let's start with the basics. I have a computer here, PC. And I have a switch, non-intelligent switch. It is not a level 3 router, or a level, yeah, it's not a level 3 switch. It is simply a regular level 2 switch, or layer 2 switch. And then I have a server over here. Okay, they're both connected with a single network interface. Give me a good IP address for this PC right here. Just give me the IP address itself. Go ahead.
143.
All right, let me throw this in here. I'm sorry, I misspoke. I left one important part out. This network is on the inside of your firewall, and it is a private network. Okay? So go ahead, do it again.
Which one? Right, 10.3.4.1.
Okay, 10.3.4.1. All right, so what am I concerned about with that? What am I concerned about? Why did I stop him mid-sentence? Yes?
Because you want it to be a private IP and not just any IP address.
And okay, so have we talked about that? Why does it have to be a private IP address? Austin?
Because it's a different class of IP address. There's class A, B, C, and D. And a private IP address are typically class A.
Well, I could have a class B network on the private side and a class B network on the public side. Go ahead, Austin.
What you said is behind the firewall, those are private IP addresses. Those are the ones that on the network side that's what it specifically has to start with being private.
Yeah, I'm not sure you guys, can anyone else describe what I'm talking about or not? All right, so let's pretend we've got a router out here. Right? We've got a router on this side and it's connected to the internet. Okay, if the IP addresses on this side of the network are private And the IP addresses on this side have to be what? Aaron? Public. Okay, so we got public IP addresses on this side and private. What's the big thing about private IP addresses? If you try to use them on the internet, what happens? Do I remember this? Yes.
Does it seem to like block the websites?
It looks like that, but what is the underlying reason for that? Quinn, do you know? Talked about this the other day. Austin, do you know? What is the thing about the whole range of private IP addresses? You can't route them. You can't route them. Okay? So let's pretend that this PC here, this PC decides that it wants to go to a website, www.hp.com. Okay? What is the process it goes through to get to that website? What's the first thing that happens? Let's have someone who hasn't answered anything yet. What's the first thing? So the PC wants to go to a website at the application layer, which is Internet Explorer, wants to go to a website, and the guy types in www.hp.com. What does that computer have to know to be able to communicate with the actual website? Michael? It needs to know the IP address. And what resolves the IP address, the host name to an IP address? Yes. The DNS, what did you say? Sorry, I misunderstood. Since I gave you the answer, the DNS server, right? So the DNS server gives it an IP address. Okay, gives it an IP address. It's going to be what kind of an IP address? Private or public? Christopher? Public IP address. Okay, what happens if you decided, and let's say that public IP address is 38.75.4.3. What happens if you decide that you want to assign all of your PCs on the inside of your network to a public IP address? It's behind a firewall, so who cares, right? I'm protecting all that. We're doing network address translation. The internet doesn't see it. So if I decide to use all 38s on this side of the network, 38.75.4.1.2.5.6.8, when one of these devices decides to go to that hp.com website, the computer is going to think it's where?
On a website, but it's not private.
Not necessarily on the website, but
It's going to think that it's on a different network.
it's going to think that it's on a different network. It's going to think it doesn't even need to route to get that other network, right? Okay, so that's why we use private IP addresses on the inside of the firewall. All right, let's start our drawing over again. So we've got a PC, we've got a server, and you as a network administrator decide that you're going to do IP addresses, assign IP addresses to all these different devices so they can communicate. So give me another IP address for the PC. Brittany?
10.8.9.3.
What dot 3?
9.3.
9.3. What's its subnet mask? Give me a subnet mask, Brittany. 255.255. I didn't hear anything after that. 0.0. Okay? Given that subnet, and that's fine, it works. Given that subnet mask you see up there, what is the network address of that PC? Frank? Okay, so the network address is 10.8.0.0. Okay? So everything that is on, and we don't even have a router yet, everything that is the PC and the server based upon our IP rules needs to be on the same network, right? If that's the case, then Miguel, give me an IP address for that server. Zero dot what? 0.1. And why did you say that? Why did you change your answer? You're right. Yeah. Well, it does have to be different, but let's go back to our IP rules. What rule up there made you change your answer? Or should have made you change your answer? The host cannot end in all 1 zeros, all zeros, okay? So, give me a subnet mask for that server, Miguel. Okay, now, can these two devices communicate with each other on this network? Gabe?
Yeah.
They sure can. Okay? What is another thing that we want to assign to these devices? Maybe. Maybe. There's another part of that IP address that we want to assign. Yes?
Gateway address.
Okay, what do we use the gateway for, Josh? What's another name for the gateway? Router. Okay? Are all routers gateways? Not necessarily. I could have two routers in here, only one of them identified as the default gateway. Typically, what is the default gateway used for? Yes, routing, but routing to what? Someone who hasn't, and Jordan. I'm routing, using a default gateway to route to what? Another network. What's the biggest network in the world? You know this. Come on, think about it. Billions and billions of devices are out there are found on the web. Just go on. You don't know? All right. When you log in the morning on this and you synchronize, you're synchronizing to servers that are found out where? When you go to www.hp.com, what network are you using to get to that server? You're using a school network initially, that goes to a router, and that router connects you to what? It's a very broad general term. The world. You're doing this on purpose, aren't you? All right, help them out. The internet. I'll give you a chance to redeem yourself here in a little bit, so pay attention. All right. So, the default gateway most of the time is used to connect to the internet, right? But not always. It doesn't have to be. All right, so let's add to our network. What's the next? If we're going to add a gateway on here, what's the next host that we have to connect or draw up here? Seth, what is the next host that we have to draw up here if we want to connect to the internet?
The router?
A router. Okay? So we put a router in here. Now, as soon as we put a router, that should remind us of another one of the IP rules. Yes, Austin?
Well, actually, no, this is the way you put it up there. One of the network interface cards are going to have a gateway and one's not because one's already connected to the network.
That is absolutely true. It's not one of the IP rules that we covered before, but you're right. One of the interfaces should have a gateway. That's correct. Okay, but what's the other rule? Yes? Say again? Well, we need to give it an IP address, but take a look at these rules up above. Of these rules, which one? As soon as we put in a router, right, on the other side of the network, or on the other side of the router, which would be out here, all of these devices, which let's say it's a server, I'll tell you what, let's draw a switch in here. Okay, so this is a server, and this is a printer. We're not connected to the internet yet. Okay? We're not connected to the internet yet, but we'll get there. All right, so to make this work, we got a lot of different stuff we need to assign. What do we have to assign? Yes?
You have to assign the...
Just give me one.
Okay, a network for the servers and the printer.
Okay, so we need a different network address on the other side of the router. Give me a network address.
Is it private or public?
This would be private because it's on, it's like, let's pretend it's on the other side of the network over here is this building,
Yeah.
and the network over here is at Riverside, which is down the street.
192.116.7.4.
7 dot what? 4. Remember, we're assigning a network address, not a host address. So what, you have one digit that's wrong, just a network address. Christopher?
Zero.
Oh my goodness. My phone is listening to my commands. So back to Christopher. What do I need to do on this network address? Put in a what?
.0.
.0. Because the network address over here is 10.8.0.0, right? Network address over here could be 192.116.7.0, could be 192.116.0.0. Let's pretend that the network address is 192.116.0.0. What would the subnet mask have to be?
255.255.0.0.
Very good. Okay. Someone explain to me why. Yes.
Alright, the subnet mask is that because where the zeros end, like you just said it was 192. That's
Where the zeros in?
or like the actual digits, and where
Okay.
the zeros start.
Where the zeros start. Very good.
So you said 116.0.0. So where the zeros started, that's where we start the zeros on the subnet mask. So it would be 255.255.0.
Okay, so if the subnet mask is 255.255.0.0, what is the network address?
192.116.0.0.
Correct, instead of 7.0, which is what we have up here. So where the ones end, right, ones in binary format, 255.255 are all ones in binary format, right? Where the ones end, that's the network address. So instead of the network being 192.116.7.0, instead it's what, Miguel? Instead of 7.0, it is what? Austin, you go tell him.
Well, I was,
Oh, I thought you were telling him.
I'll do that.
Okay, Miguel, one more time. Where the ones end, right? Where the ones end, that's where the network address starts. So instead of 192.116.7.0 as a network address, what should it be? Okay, in this IP address, where do the ones end? What's that? Yeah, the last two. So that's exactly right. So 192.116, finish out the network address given this subnet mask. Say again? .0.0. You understand that? If the subnet mask were 255.255.255.0 and the IP address were 192.116, yeah, I mean, this is kind of messy. That's probably what's confusing. Okay, so I have an IP address of 192.116.35.74. Okay? What?
Well, see?
Looks like the word legendary.
Hey, whatever you say. I can't read my own writing most of the time, so that works for me. Okay. Here you go, Austin. I want you to type. No. Okay, 192.116.75.4. Is that better? All right. Oh, you're funny. Yeah. All right, Michael, give me.
We have legendary handwriting.
All right, there you go. Thank you, Austin. If the subnet mask is 255.255.255.0, back to Miguel. Take a look up here. Okay. Our rule says where the ones end, or actually the way of IP addressing, where the ones end, that is the network address, and then you add zeros on the end of that. So where do the ones end in this IP address? Correct. So that if the ones end right here. If that's the case, then what is the network address for this host? 116, yes, sir. Very good. Okay? Everybody understand that,
I
right?
have a question
Yes, Austin.
about the subnet mask. So, I don't know if I've written something down wrong, but when I had the 192.168 for class C, the subnet mask, I put 255.255.255.0. But but I wrote it as 192.168.0.0, is that correct?
As the network address?
Yeah.
No, because if you have a host, give me your IP address again.
192.168.0.0
Is the IP address of the host?
tells you the network address. I don't have it, it's just like an example.
Okay. And what's the subnet mask?
255.255.255, so wouldn't there have to be a third number there?
There would not.
There wouldn't?
No.
Why?
It could still be 192.168.0.0. The ones end right here, that's still a network address. The network address can end in 0. Can, C-A-N, okay? It can end in 0. The host address cannot.
Oh,
So, given that, give me a valid IP address with that subnet mask, Austin.
192.168.0.1.
Right. .1 through .254. Okay. All right. Let's
Let's
get.
add that to our rules.
It's a given. It's not necessary. You can add it if you want on your, just to keep your notes straight. That's fine. All right. So, given our network, let's take a look at this again. So on the left-hand side, we have a network address of 10.8.0.0, and then we have a router right here. What next has to be assigned? And we've got a, let's just, you guys got it right, let's just say the network address over here is 192.168.5.0, because I forgot what it is, with a subnet mask of 255.255.255.0. Okay? What else is missing? Give me another component of this network in order to be able to make it work. Yes?
First, you have to set up a proper host.
For what? I can't hear you.
You have to set a proper host, IP address, how to do the network.
Correct. So give me a host address for what? I've got a server, a printer, and then a router, the two interfaces.
Oh.
Server? All right, give me an IP address that within this network that works for that. 5.4. Solves all our rules, right? Give me a subnet mask for that. Same subnet mask as our overall network. What is another way of indicating that subnet mask, that 24-bit subnet mask? /24. Okay, good. So that's assigned to the server. Give me another component of all of this. We've got an IP address and a subnet mask. Give me another component. Yes?
192.168.
For what?
Oh, the printer.
Okay?
192.168.5.7.
5. Sorry guys, I still can't hear. Okay, give me a subnet mask.
255.255.255.
Okay, so 24-bit, that works. What else are we missing? Awesome.
Gateway address,
For what?
the server and the printer.
Server and the printer? Okay. So what would the gateway address be?
The IP address of that router.
Yeah, so what would that be?
192.168.5.1.
5.1. Okay, and that's assigned to this interface, right? Everybody see that? 192.168.5.1 with the same subnet mask. It fits all our rules. That interface is on the right-hand side of the network. Therefore, it needs to be on the same network. And this is something that many of you did on that homework. You actually assigned the IP address for this side of the network. You assigned for a gateway the IP address of this interface, and vice versa. Instead, the gateway address needs to be on the same side of the network as the hosts. Okay? So, Christopher, give me an IP address for this interface on the router, on the left-hand side of the router.
So 10.8.9.4.
Okay, and a subnet mask?
255.255.0.0.
Very good. Okay, it's on the same network. It's different than all the other hosts, but but it's assigned to the router. If on the left-hand side we have an IP address of 10.8.9.4, what is the next step, Austin, based upon your logic before? What do I need to assign?
The gateway address.
On which device?
On the server.
Which server?
The one that's to the right of that router.
Okay, so over here, this one?
Yeah.
Give me an IP address for the gateway on that server.
192.168.5.1.
5.1, which is this interface of the router. Okay, does everybody understand this? If you can do this, you can set up a wide area network. And what did I say earlier? You're ahead of the majority of the network managers, network administrators that I see in small businesses today. If you can do this, you're already to the point where you can set up an IP network, which is a pretty cool thing to be thinking about. Put it on your resume. I can address a wide area network. But that's yet to be seen when we take the test. Okay? Yes?
Can you show me like an example of a drawing that would indicate like two different networks? Because that was where I messed up when I did the homework. Everything I did was fundamentally right.
We're going to get there.
Networks, but
We're going to get there.
yeah,
It is actually what you're asking for, because what you're seeing here is two different networks, right? We have a network on the left-hand side, we have a network on the right-hand side.
So it
I think what you're asking-
router, right? On the left side is where it has, or well, the gateway. Yeah, I know what you're saying.
I think what you're asking is three different networks.
Or yeah, sorry. Yeah.
Okay? So let me indicate that, because that's what was on the homework assignment. Okay? So let's draw three different networks. Give me the first component. Give me a couple components.
PC,
Okay, so we got a PC.
then you guys need to go to your switch,
That'll go to a switch.
then you can have a server,
Where?
and that, I guess it's somewhere over there. and then we'll go
Where's
back to
over
the
there?
switch.
Awesome.
On the screen, like. No, like draw it like to the
Left, right, up,
to
down.
the right, up to the upper right of the switch,
Okay?
and then put a server there,
Okay?
and then I guess you have your switch go back to a router.
Okay, where's the router connect to?
The router is going to connect to another network of some kind, right?
Like that? That's a router.
Yeah,
Now what?
and then that's going to go over to, I guess, another PC.
Probably another switch, don't you think, first?
Yeah.
It could go directly to a PC, but more than likely it's going to go to a switch, and then we're going to have a PC. Okay, Taylor Early, take me from there. What else? Take a look at the drawing up here. What else? If he wants a third network, what are we going to have to do? We can have a printer, but that's not going to give us a third network. Give me a third network. Mind the fees.
Off of the first switch, you can do the router and go
Okay, so we have router 1, and we have router 2, right? Taylor, back to the drawing, what's a different location I can put that router to? He's right. What's another way of doing this?
You can take off the other switch.
Correct, very good. Router 2. All right, so let's get rid of this router because we don't make it too confusing. All right, now, let's say that router 2 connects to the internet.
Wait, so the PC1 and server 1 connecting to the first router on top, that's one network, and the switch and the PC right there, would that be a second network?
Correct, so this, all of these would be network 1. Okay?
Yeah. because you-
This PC would be network 2, and then the internet would be network 3.
Oh, okay, so I guess it would be like any place that occupies a network interface card is a network.
I think a better way of saying that would be any place on either side of a router would be considered a separate network. Back to our IP rules, right? All right, let's get rid of these. Okay, very, very quickly, let's go through some IP addresses with the subnet mask. Give me the IP address and subnet mask of a PC. Let's do the PC on the right-hand side screen. Do you have a question?
Yeah.
Go ahead.
Which side's the private side?
You tell me. Somebody tell me. Question was, which side is the private side? Austin.
Everything from router to Mac. So like all the PCs, servers, routers, and stuff is all in her.
Why is that? You're absolutely right. Why is that?
It's that way because nothing is connected to a public port or a public pathway, I guess.
Yeah, actually, I need to redraw this because it actually goes kind of cuts through the middle of this router, right?
Yeah. Pretty, yeah.
Which side of this line is the public side?
The public side is all.
Is the right side? I'm sorry, I was asking you. Okay, so this is all public over here, and this is all private over here, right? Because you control this, and this router does something. We talked about it the other day. There are 3 initials in this acronym. This router does something for us. If we have a public network on the right side and a private network on the left side, what is it that it does? 3 letters. Yes?
DNS.
Okay, so 3 more letters, because you're right. It is. You're absolutely right. There is a DNS server, otherwise we're not going to be able to get to like websites. Yes?
Is it NAT?
NAT, and what does that stand for?
I have no idea.
I know.
Hey, you're halfway there. Seth, talk to me.
Network address translation?
Network address translation. Okay? Network address translation is a pretty critical component of what a router does that's connected to a public network. And here's why. Was that your question? Go ahead. Go ahead and ask your question, and I'll come back to it.
When you're like on a computer or maybe you're talking to it says your NAT type is strict, is that what it's talking about?
NAT type is strict. That's a new one on me. I don't know. And where do you receive that message?
When you look at your network,
Let me finish.
sorry.
Go ahead.
That's right. So your network says like your output is your NAT type strict, so you lag really bad.
And you can't, and then it's harder to find matches as well.
Does anyone know the answer to that? I don't know. I don't know, because that's a term that's not necessarily a general IP addressing term. It's more of
Maybe
a...
it's taking longer because
Hey,
it's
possible one. Let somebody else have a shot at this. Yes?
I'm pretty sure that it has to do with the number of connections that your computer is allowing and taking back, because it's all going through your internet connection, but because the game itself is a program and it takes and probably uses different resources than your typical browsing stuff. If your firewall settings or whatever on your computer are set to a stricter setting, then your that application would have to force all this traffic through a different port.
Okay, here's what I want to do. Today is Tuesday. By Thursday, if you two can come up with a written version of that and then put it in the collaboration space, right, together, then you get 5 points of extra credit. Because I'm guessing it's something I've never heard of, but it probably applies. How many of you are gamers? Yeah. Okay, it's a different world. Thank you, Brittany. Right? If you're all gamers, then chances are you've seen this at some point. So you two find out the answer, and I'll give you 5 points extra credit. But you need to put it in collaboration space so that everybody can see it, not just in your own. Okay? And cite your source. Not the guy at GameStop. Because she's not here today. Caitlin works at GameStop. She's not here today, so she can't be a good source. All right, let's move on. Okay, so we've established that everything on the right-hand side is public. Everything on the left-hand side of this network or that line are private. So give me some examples of private IP addressing schemes. Let me get rid of all this stuff up here so you don't get confused. Give me something other than what we've used so far. So far we've used 10.0.0.0. And we've used 192.168.0.0. Give me another one.
172.16.0.0.
Yep. Oh my. Sorry. 172.16.0.0 with a subnet mask of what? And that is depicted how? /16. Is there anyone who does not understand what I just did up there? 172.16, that's one of those 3 ranges of private IP addresses. Do you understand why I put the /16? With because that's really important that you understand why I did that, okay? Now, let me just kind of take you back. Last week, you guys didn't understand that /16. And any time that you get some information from an ISP who's going to tell you what IP network you need to use on the outside of your router, they're going to show it like this. Last week you didn't know it. Now you not only can configure your own private network, but now you can start to configure a network that connects to the internet. Now you all think that's not a big deal, and it's not for home, because you plug in your router and they magically give you an IP address, right? How do they give you that IP address? How does the internet service provider? I should see like 50 hands, even though we only have 34 students.
You raise both hands. Yeah, there we go. Austin started the movement.
Yes, why? It gives it to you how? DHCP. Gold star for the person after he or she raises their hand tells me what DHCP stands for.
Aw.
I'm not saying extra credit, I'm just saying gold star. Yes?
Dynamic host control protocol.
Very good. And there's another way of saying that too. We talked about this here. Dynamic host configuration protocol. Okay, DHCP. When we get to the server side of this course next semester, we will configure a DHCP server. So we're starting to put all of the pieces together for you to be able to support a business network. Because that business network is not only going to have devices like these that have to communicate to each other, printers, workstations, servers, routers, switches even get IP addresses occasionally. Not only have to be able to communicate with each other, but they need to be able to communicate to the internet. Okay? All right. Any questions about what? Yes?
Can we private network, or not network, private host address end in 0?
Can a private host address end in 0? Who can answer that? Can a private host, a host that's sitting on a private network, end in 0? Josh? No. The rules of IP addressing apply whether it's public or whether it's private. Okay? Let's say a host address, or you find an IP address, and this goes into material that we haven't covered so far in the book, but is part of your reading. Let's say you see an IP address that's 192.168.1.255. Does anyone know what that tells you? 192.168. You're not going to see a host with that IP address assigned to it, but you may see that IP address identified somewhere. Michael? So the IP address is as follows: 192.168.1.255. We know that we can't assign that to a specific host, but you may see that IP address. What is it?
It's like the end of the possible ranges.
It is the end of the possible ranges, but it tells that PC, I can actually communicate through that IP address. Does anyone know what that does? No one? I'm almost positive it's part of your reading. All right. It's another one of those IP rules. Go up to your list of IP rules and add to it. I think you have a separate page that's identified to that in OneNote. The .255, any host or any broadcast that ends, any communication that ends in a .255 means that PC wants to broadcast on that network. So here's an example. If I have a source PC with an IP address of 192.168.1.37 with a 24-bit subnet mask. By the way, if that 24-bit subnet mask is in place, Aaron, what would be the subnet mask? Is a 24-bit subnet mask? No, if I have a 24-bit subnet mask assigned to this IP address, what would that subnet mask be in decimal format? Frank, help them out. This is what we just covered up here, guys. I said it was absolutely critical. Okay, 172.16.0.0 has a subnet mask of 16 bits. What does that make that subnet mask? Do you know now? the IP address is 192.168.1.37, and we have a 24-bit subnet mask, what's a subnet mask? Very good. Very good. I'm sure it's the way I asked the question because it sounds like you know the answer. 255.255.255.0. 24-bit subnet mask means 3 octets are used for 255s, right? That's where the ones end. Okay, so back to our original question. If this PC has that IP address, 192.168.1.37, okay, you may see a packet. All right, hold that thought. We'll come back to it after break. Would you stop the video for the remote students, please? Yes, go ahead.
Okay. So,